Hello everyone, welcome to the session on API management for AI, governing ingress and egress traffic. I am Pubudu Gunatilaka, I'm the head of architecture for API management business unit at WSO2. So I looked into the architecture and other design considerations when it comes to WSO2 API management solution, which is our open source API management solution. Right. So today I'll go through what we look at in terms of ingress and egress API management. So just to start things off, so if you look at the AI shift right now, uh, if you start your applications from day one, you are basically having AI inbuilt as a first class feature. So with these changes, you are basically utilizing more and more AI services like OpenAI, Asia, Anthropic, Mistral. Likewise, then there is a surge in the egress traffic, and we have to look at how we deal with the AI traffic or the egress traffic as well. Now, if we go in detail and if you look at the traditional API management, which is specifically built for Ingress, so this is how your API management solution looks like. If you look at the control plane, you have the publisher, developer portal, analytics, and even admin portal where you do certain admin stuff there. And then you have the key management. So these are all available in the control plane for all your API management functionality. Then the data plane side, that's where your gateways are running, that's where you do rate limiting, and that's where you have your microservices, your all the data services are there. So your web and mobile application are basically utilizing your services through the API gateway. So this is the high level architecture and more like a centralized API management that we can see in a traditional API management architectures today. Now, if we look at the full spectrum when it comes to API traffic, you have set of services that you expose those as APIs. That's where the mobile and web application utilize. Then you have set of services that you consume third party APIs that are available. These APIs can be Shopify, Salesforce, likewise third party services that you can consume in your day to day applications. Then there's the third one that I explained in the earlier, that with the AI services coming into this picture, you have now services that basically consume more and more AI services. So we have to deal with all these three use cases. Now, if you look at the English part, that the site we have mastered today. So if you look at from the traffic point of view, these are the traffic that comes from your external consumers to internal. Then we have set of controls like the policies. We look at the authentication, we look at the rate limiting, we look at the transformation likewise. Then from the observability time side, you basically look at the usages, you look at the latencies and the errors just to figure out and understand what are your consumers. From the use cases point of view, you have the partner APIs, you have the public APIs, you have web and mobile applications that consumes these APIs. For example, this can be an external mobile application that calls your payment API likewise. Now, from the egress side of things, um, the traffic is more about the services that are they are in your internal system that consumes the third party API. So the traffic is going beyond your system. Then the controls are more like the credentials, policies like data masking, and different policies that mainly looking at the egress side of things. And from the observability point of view, you are looking at the failures, you are looking at the cost, you are looking at the dependencies that you are dealing with in these third party APIs or the services. From the use cases point of view, you are looking at the fintech APIs, B2B even the SaaS APIs that you consume. So, for example, this can be Shopify API that basically consumed by your internal system or internal services. Now, if you really look at nobody governs egress today, so if you compare this in a real world case where if you look at from the kingdom side of thing, you govern, you monitor the front door, but if you look at the back door, robbers basically slip through from your back door, which is not guarded right now. So that's the reality. So if you look at the cost for ignoring egress, you have leaked credentials, you have insecure calls happening because you don't monitor this, you don't look at, or you don't basically consider this. So there are can be third party dependencies that you have to deal with and things like that. And then due to these issues, you have compliance and policy breaches, and also you have to look at unmonitored use of paid APIs as well. You don't know what are the uh, APIs that have been paid and what are their consumption likewise. And there can be unreliable integrations that you don't have a clear view. So this limited visibility basically add more troubles where in your existing API management systems. So this is where the egress coming into the picture, where I can secure your credential. We have the centralized management for your all tokens and secrets. Then you can also control your dependencies, like you can block unapproved domains, you can enforce policies, and also you can look at the compliance side of things, and you know what are you are dealing with, and you know the cost of these resources and the usages likewise, so you get more visibility into the things that you are dealing with. From the reliability point of view, these can be API calls, these can be services call that you haven't dealt with, and with the retries, timeouts and circuit breakers, you can make your system more reliable and resilient. So this is what basically brings egress and solving your problem to some extent. But egress is not just enough. If you look at from the AI side of things, now we have more issues where you have to look at the prompt security and consistency, which will basically sanitize and standardize and protect prompts. And then there can be semantic guardrails to prevent unsafe and biased or toxic outputs. And also if you look at from the cost aware routing, now we have to look at whether we balance the performance or whether we go for usage cost across the models that we utilize in our Gen AI applications. Now, from the context management point of view, we have to make sure you have multiple interactions with different LLMs based on the use cases likewise. Then also you can help with caching where you can avoid repeated expensive AI calls as well. So this is the layer that we have to bring on top of what we have. This is the layer that AI gateway, which basically you have your Gen AI application, then you have your AI services. Now in between you have the AI gateway, which adds to value your Gen AI applications, and it will make your lives easy. Now, with this, if we look at deeper into this AI gateway, starting from the model routing, you can route to different models based on different models or based on the providers. You can do round robin, you can do failover, uh, you can do weighted round robin likewise. Then when it comes to token based subscription, you can have different rate limiting at the subscription level. You can have different guardrails to protect like the hate speech, hallucination, content safety, jailbreak, PIM masking. Even you can do semantic prompt guard as well. Then on the prompt management side, you can do prompt decorating and prompt templating just to make sure your prompts are secure. Just your prompt are secured with more system values in it, so that your users are basically safeguarded. Then from the intelligent routing, that's where the intel adaptive routing is being handled. So based on the use case, you can do routing as well. Then the semantic caching will help you to reduce your cost. Then on top of these, you can apply certain security policies to govern all your secure your AI services. Then from the observability side, this gives you how your APIs are doing, what are the most used models, what are the most used providers, and this will help you to understand how the business is growing, what are the most used one, and to look at how you need to spend your money in the coming months likewise. Now, if you move from APIs to agent, this is the future is heading. And if we start looking at how agentic workflows operate, so there are three steps to in it. So at the planning stage, you look at the use case. You basically divide this entire uh, use case into several subs uh, plans, and then you come to the next stage where you execute these plans. So execution can be like API calling, it can be like function calling, or you may run some code likewise. Then at the third stage, that's where you iterate through your plan, understand what are your results against the goals that you have basically planned out in the initial state. So if there are any adjustments are required, you can iterate through the plan and basically get that done. So this is the high level idea, and if you put that into a workable solution as a AI agent, it will get some inputs. These inputs can be the documents that you upload. These inputs can be the chat history that you have, or likewise. So you, as an AI agent, consume these inputs, and it will look at the knowledge base it has. It will look at the memory it has. This can be the chat history likewise. Then finally, it will execute these into an actionable item, where it can be like a tool calling, can be a service calling, or it can be like a sending a text likewise. So this is the high level idea how you do the operation when it comes to agent operating systems. Right. So if you look at from APIs are the most powerful building blocks, and it has been considered as the backbone of modern software. From REST to GraphQL to webhooks, we have built structured and we have fixed endpoints. Likewise, then APIs are not going to obsolete; they are the foundational. So every API is a potential AI tool exposed with right context and intent. Now, the thing here is that API alone aren't enough for AI. If you look at REST APIs, APIs have well structured interfaces where you have defined the requests and responses. If AI is asking for something out of scope, something out of menu, it really API really struggle to deliver that, because it is now binded with requests and responses, and it needs to basically understand the session level information as well, because if you look at APIs are more like a stateless transactions. Now AI is coming into the picture, it needs to understand some history or some context as well. So if you are dealing with several APIs, then you have to make your AI agent have some custom glue code, so that you deal with different APIs differently likewise. So likewise, there are some issues when you are try to deal with these APIs with today's context. So this is where the MCP comes into the picture. MCP is considered as the model context protocol, which is an open protocol that standardizes how applications provide context to LLM. So if you take an AI agent basically, let's say it interacts with multiple uh, APIs, then it has to uniquely call these APIs. Now, this will be resolved MCP coming into the picture. Now, AI agent has a unified API thanks to MCP, where the MCP will take care of calling the other uh, APIs in the unique way. So that's the high level idea when it comes to MCP. Now, with the MCP coming into the picture, now you have a more broader picture with where you now have the MCP server management as well. So, as a developer, you will manage this MCP and you manage the tools, you manage the life cycle, and you can add certain policies, and also you can theming for your MCP hub as well. So once you develop the MCP service, you push it to the MCP gateway, which will help you with the runtime where you have your MCP service. Then you can apply certain policies as well. Likewise, then MCP hub contains your MCP server. That's where the agent developers come and discover all your MCP servers. So this is the high level idea of it. Now if we go into details, now if you have set of APIs or API proxies, you can convert these as MCP server tools with just one button click. You can convert your existing APIs as MCP tools. You can enrich these structured uh, um, tools with more descriptions and other metadata. You can add certain policies like security, rate limiting, and other governance policies. So once you are done with that, you can push these MCP server into MCP hub so that the agent developers can come and discover that. Then the other part is, let's say you have a remote MCP service, you can bring these to an API management platform where you can basically enrich this further and do some policy enforcement. And then once you are done with that, you can push it to a MCP hub. So the MCP hub is a dedicated discovery portal for AI agent. It only contains your MCP servers where agent developers can come and discover this. You can theme it according to your MCP hub theming that you want to have it. You have the playgrounds to try out these MCP servers like us. So this is the high level idea how you do the MCP server management uh, with consumption. So, so today's session, I basically went through the AI shift where you have more AI services usages from day one with the application trying to integrate with the AI services. Then, as you don't manage the egress part of it, there are a lot of issues. That's where you have the egress gateway coming into the picture with more focus with the AI gateway where you can add QoS to your AI services. Then you have the now idea on how you convert your APIs as AI tools so that your AI agents can consume these tools with the MCP support. So this is the high level idea what we discussed today. I hope you had a good understanding on the things what I covered. Thank you very much.